All right. Hey everyone, I'm Stefan Graeber. I'm the project leader for LXD at Canonical. You might usually associate LXD with containers. That's no longer quite the case, so we'll go through some of that and see how things line up now. First, we'll start with what we're kind of best at, really, which is containers and system containers specifically. System containers, you've got a shared kernel. They are containers. They're the oldest type of container. That's what you might associate with like BSD jails or zones, OpenVZ, and these days LXC and LXD. They behave like a standalone system in much the same way as virtual machines do. They have low overhead, and there's no virtualization overhead or any of that stuff going on. And they're pretty easy to manage. It's just a bunch of processes on the same kernel. So that's what we're mostly known for. It's what we've been doing for a long time. Now, on the other side, if you look at virtual machines, you've got a bit more separation going on. So virtual machines, virtual hardware to some extent, and virtual firmware or virtualized firmware. It is hardware. It effectively requires hardware acceleration to be meaningful. You can run it completely software, but performance kind of sucks at that point. The main benefit, obviously, is you can run just about anything. There is no constraint on it being Linux of the right version and everything like containers do. In case anyone didn't know what a VM was. Now, as for LXD itself, it's a modern system container manager and VM manager now. It is written in Go. It relies on the container path, uses libLXC to talk to the kernel and drive containers. On the VM side, we're using QEMU to run virtual machines. It exposes a REST API to our clients. The REST API has been designed to be quite simple with multiple bindings available. And we've got already supporting a number of tools up there, OpenNebula, Ansible, our own CLI, or whatever other tools you might want to run. And it's designed so that you can run multiple LXD servers or like either just on your laptop or on multiple machines and support migration and operation across multiple systems. Either just individual systems that then exchange containers and VMs and images, or as a unified cluster that we'll also go through in a tiny bit. Now, for where you might have seen LXD, LXD is used on Chromebooks. So when you install Linux on a Chromebook, for example, it effectively runs a LXD host that then runs a Debian-based container with a lot of fancy pass-through features in place there to get you GPU, USB, whatever access, all that stuff going on. They also have nice integration to do snapshots and backups and file transfers straight into the Chrome interface. Another place you might have seen LXD other than your own systems is in Travis CI. So if you run Travis and you run jobs that are non-x86, so if you run ARM64, if you run PowerPC, or if you run an IBM S390, those workloads on Travis are running inside LXD containers right now. Okay, back to what LXD is. So LXD is designed to be very simple to use. It's got a clean command line interface, simple REST API, and pretty clear terminology. In many ways, it acts like a small local cloud on your system. Originally only with containers. Now we've got multiple options there. It is fast, so it's image-based. We support multiple storage drivers with whatever copy on write feature they might have. We also support those features for network migration, and we support direct access to hardware whenever possible. We usually aim to be safe by default. So for containers, that means using all the kernel security features, all the namespaces, LSM, seccomp, capabilities, etc. For virtual machines, we do intend to use more of that. We've not actually done AppArmor and seccomp around QEMU yet. It's coming very soon. Right now, we do privilege dropping and true root, and then the VM itself uses secure boot in the VM. And it's pretty scalable. You can go from like a single install on your laptop to clusters of hundreds of nodes running tens of thousands of containers. And these days, mixed virtual machines. As far as what we can run, so that's the picture for containers right now. We do generate about 300 daily images of different distros and releases on 6 different architectures daily. For VMs, we will get there. We are working on our tooling right now so that as it builds the container root file system, it then has a follow-up step of taking that file system, installing kernel bootloader, and spitting that out as a VM image. So we end up having the exact same content as far as the operating system for containers and virtual machines. That's coming up soon. Right now, the only image that works out of the box is Ubuntu, because we already had ready cloud images available in the right format and everything. On the clustering side, so that's an interesting aspect of LXD. We've got an extremely easy way to cluster multiple systems together. We don't have any external dependencies. It's using DQLite as a cluster database. There was a talk in the main track about an hour and a half ago on that database. That's what we use for LXD clustering. The API, when you talk to a cluster, is the same as the one you would talk to just a single node LXD on your laptop. If you can actually take a command line or script or whatever that doesn't know what a cluster is, and you run it against a cluster, and it will just work. The cluster will just do some amount of balancing for you and try to make its best guess as to where to put things. If you are cluster aware, you can obviously do a lot more and like pick exactly what machine you want and get hardware details and stuff on the different cluster nodes. But you don't have to, and just like a superset of the API effectively. It can scale to thousands of containers on dozens of nodes. We actually have gone all the way to 100 nodes and like tens of thousands of containers now. That works fine. Density for virtual machines obviously goes down because you can't quite run multiple thousands of full OS virtual machines on one system. It gets a bit tricky. But that's not really a LXD problem so much as how much your hardware can actually achieve. And we've got support for multiple architectures and mixing multiple architectures within the same cluster. Then LXD does the right thing based on what image you're using. It picks what node is actually capable of running that workload. Now, for the VM side itself. So, as I mentioned briefly, we've gone pretty much legacy free because it's new to us. We don't really need to start supporting old machine types to run DOS or Windows 95 or something. It's not something we really care about. We care about acting like a modern local cloud effectively. And so only really care about modern distros, which means that for both x86 and ARM, we've gone with UEFI as the only firmware we have. It's got secure boot that you can turn off if you don't have a workload that can boot with secure boot. We do VirtIO devices only. And currently we're based on QEMU 4.2. Technically, you can go to lower QEMUs, but that's what we test with, really. API and everything is pretty much the same as containers. So far, all the tools we've seen that were interacting with containers can interact with VMs, and they don't really notice a difference. So there's no particular VM knowledge needed for anything that's like any tooling that's targets LXD can target LXD VMs, and it will just work the same way effectively. The VMs integrate seamlessly with existing LXD configuration you might have. So your LXD networks, your LXD storage pools, your LXD projects, LXD profiles and configuration. Those are effectively shared between VM and containers on the same system. You don't need to duplicate anything, which is really the main benefit for using LXD to manage your VMs. If you had two different solutions on one system, it gets a bit annoying to manage. But now you can just use one thing and it does it all. LXD VM support was introduced in LXD 3.19, which was released mid-January. So it's pretty new. We've been working on it for maybe the past 6 months or so, on and off. Ironically, supporting VMs, very easy as far as we're concerned. Like the actual work to drive QEMU instead of LXC and running virtual machines probably took us just a few days. The main issue we had was actually refactoring our storage layer so that we can store blocks or file systems and handle that properly. That's what took us way longer than the VM piece ever took. Review of the LXD API and kind of how things are structured. So instances is obviously what most people care about. That's either containers or virtual machines. So it's different instance type that indicates which one of the two it is. You can snapshot or back them up. They're created from images. Images can have nice names, so you don't need to give them like a SHA-256 or whatever. it can be clustered. So we've got the cluster level part of the API that lists all the nodes and how things behave. You can also manage networks that creates bridges that you can then connect your instances to. Storage pools, and that's pretty obvious what they're used for, but you can create multiple storage pools on different storage drivers, different block devices, and then assign containers or VMs to that. You can create custom volumes as well and then attach to your instances, and those custom volumes can also be snapshotted. Then we've got some amount of internal components that are mostly for authentication and tracking of what's going on, and some APIs against the instance itself, so for things like file transfer, executing a command inside it, attaching to the console, or publishing it as an image. All right, now for the interesting part. Let's see how that stuff actually works. Okay, so what I'll be doing is hoping the network works, it does. I've got two systems, so we're just doing initial install. So they've never really done an LXD thing before. LXD is installed, but never been configured. Yeah, I can try to figure it out. Yeah, it's probably about as big as it's gonna get without it cutting everything afterwards. Yep. So you can say, because I've got two systems, I might as well create a cluster. It's so easy, why not? So we'll just create one. I just need to enter its own IP, just this one. We're not joining an existing cluster, we're creating one. Choose a password. Yeah, storage would be nice. Can let it pick whatever it wants. ZFS is what it prefers on this one. Default size is okay, and the rest should be mostly fine all out of the box. There we go. And that failed because it's a demo, yeah. And also it's cutting on my screen, which is not super convenient. Yeah, okay, that's annoying. What's the actual error? Oh, there we go. Cannot assign request. Oh, did the server actually change IP? Because that'd be annoying. No, it didn't. Okay. Let's try that again. I probably just typoed the IP address at that. Oh, was it? Hold on. Yeah, it is 46, so they actually swapped IPs between the two. That's nice. Because I redeployed the servers and yeah. Okay. So not joining a existing cluster. Want to set it up. I just hope it didn't get too far in setup, because otherwise it might get a bit confused now. Let's see. Please don't be confused. Please don't be confused. Woohoo! Okay. All right. So I just need to update my notes because those IPs are not the way I was expecting them. Okay. So let's go on to the second one now, and hopefully this one is 47. It is. Sweet. Okay. So they literally just swapped IPs. Okay. Okay, yes, we're joining an existing one this time, which is on 1646. Yes, the password, there's nothing to wipe, but sure, and okay. And yay, we've got a cluster working. So now if I do cluster list, we'll see we've got two systems joined in there. The first one is running the database. Because you need quorum for the database, and you can't have quorum when you have only two systems. Only one runs the database. Once you reach 3, then all 3 run the database. So first thing we'll do is we're just going to edit the default config for instances to add a bit of cloud init magic in there. That's normally not needed if you only run containers. Also, that the text editor is messed up. Hold on. Okay. Okay, but because we're running virtual machines and they don't really have any other way to get their config, that effectively just sets the new password to Ubuntu through Cloud Init. So just put that in place in that profile. Then let's create a container real quick. So just pulling a CentOS 8 image. Okay. There we go. Right. So There we go, we've got CentOS 8 running in a container. And now to show the difference with running a VM, we effectively still tell it what we want and just do --VM. So it's gonna go do the same thing. Also because we're running, I'm gonna do things in parallel because we're running a bit out of time. So as far as other things we can do, so security, secure boot, false because Windows, limit CPU. So we're gonna, that's on my own laptop. I'm just spawning another VM based on the Windows image I created, where with 4 CPUs, 8 gigs of RAM, and not turning off secure boot because otherwise the I don't have a WHQL driver for the disk, so it's not happy and doesn't boot. Anyway, back to the cluster, just waiting for that VM to start. It's unpacking the image. Obviously, VM image is quite a bit larger than just a container image, so it takes slightly longer. There we go. We need to add a config drive right now, which gives it access to the Cloud Init config. So that's we just added disk device for that. And then we can start the VM. Takes a tiny bit. Come on. That's running on really old hardware. It's like 10 years old servers that I've got laying around in the basement, so it's a bit slow. So attached to the console. So we see grab. That's booting. And get to a login prompt eventually. I didn't give it any extra CPU or memory, so it's running with 1 core and 1 gig of RAM right now, so it might have been a bit more generous to probably have booted faster. Okay, Cloud Init is running, which means we're about to get a login prompt. Come on. You can do it. You can do it. There we go. Yeah. Oh, that's interesting. I think I probably raised something with Cloud Init. Anyway, like the login prompt worked fine. So now for the, so right now if we look outside of, there we go. Outside of this, we'll see the VM is running. We've got its IP that's been retrieved from a DHCP server. That's fine. But if we try and look at more info on the VM, it doesn't have the list of processes or any of the extra detail because it's a VM and it can't just attach to it like a container would. But that's where we can do things a bit different. So we've got a 9P drive that's exposed by LXD out of the box with an install script that just adds some systemd units. Which if we then reboot the VM, it will start back up, starting those units that will run a VM agent that then talks back to us. While that's going on, I can just show that local VM has started. So Windows 10 started with an IP. Because Windows is weird and it can do SSH these days. You can actually SSH into it. If you prefer PowerShell, you can also spawn it from there. If I can type PowerShell properly. There we go. So that's a thing. I can't remember which is which. There's PowerShell exit and the other one is quit. Exit and exit. Okay. Or obviously X3 RDP. So that's Windows. Now back to the Linux world. So that VM should have rebooted. Yep, what a login prompt. Now if we look at the list, we should still see the same thing. Let's see if that works. Yep. So with that, I just spawned a shell inside the VM. That's done through our agent in a VM. So if we look at the process list, we actually see bash being a child of LXD agent. That's going through vsoc. So even if you look at the network, yes, it's up. But if we fix that, like we still have the shell, everything still works. The same API can be used to do file modifications. So you can pull a file through it, it comes from the agent, and just push back into the VM. If we get the shell back inside it, it's there. That also gives us more details. So if you do info now, it gives you number of processes, it gets you IP addresses for all in interfaces, counters, and stats and stuff. All right. Need to kind of rush now because I'm a bit behind. So what's next? We want images on all distros. That's obviously our next priority. We want to be able to live update a bunch of devices and configs on the VM like we do for containers. Right now, you need to restart the VM. More security, I mentioned AppArmor, SecComp. We want to put those. We've got all the generation code already for containers. We just need to wrap the VMs with it. Number of feature gaps we've got compared to containers. We want to fill quickly. And the agent right now only works on Linux. We want to make it work on Windows. Given that there's a new Virtio vSoc driver for Windows that's been in the works, we hope to use that. LXD itself is available on Linux, Mac, and Windows, but the daemon only runs on Linux. But the other ones, you can use the clients to connect to a remote LXD. Contributing to LXD, it's written in Go. It's fully translatable. It's got API libraries in a number of languages. It's Apache 2 license. There's no CLA or anything. And we've got a pretty active community that can help you with issues. And that's it. I've got a bunch of stickers here if you want to grab some after this. And we might even have 3 minutes for questions. OK.
At the start, you showed LXD as both across multiple and in individual nodes.
Yes.
Same API in both cases?
Yep. So, yeah. Right, sorry. So the question was about the API when talking to a single node or talking to multiple nodes. Yes, it is the same API. There's like an extra field in some of the objects that just tells you where they are. So in the structs you get from the API, there's going to be like an extra field telling you location to know where something is. But if you don't know about that, you can just ignore it, and that just still works. OK, it's going to be hard. I think you had your hand up already. Yes.
Do you know if there is any plan to integrate this in MAS?
OK, so the question is whether there's any plan to integrate some of this in MAS. The answer is yes. MAS has KVM pods right now. That is being replaced by driving LXD. That was one of the drivers for this work. So the idea is to move away from MAS talking to libvirt and moving to MAS talking to LXD. Let's go there. Okay, so the question is whether we plan to backport the VM to stable channel. The answer is no, because we've got 19.320 are technically stable releases with that support. The snap itself is available all the way back to Ubuntu, say 14.04 or even CentOS 7 or quite old distros. So we test on that, and that should work fine. We've got an LTS release, LXD 4.0, that's going to be coming up within the next 2 months. That's going to have VM support. So for those who want the 5 years LTS guarantees on LXD, 4.0 is what you're going to want for that. Let's go here.
What is the image type that you use in order to spawn the image in the virtual machine?
Sorry?
What was the image type that you used?
Oh, to spawn which one? Also,
The virtual machine.
yeah, so for the virtual machine, the name ends up, so the question is like, what's the image type that was used to spawn a virtual machine? So for a lot of our images, for like the Ubuntu images, the exact same name are gonna line up for both containers and VMs, because you've got an Ubuntu 18.04 for both. And that's why we've got the -- VM flag. That's just to tell LXD, hey, I actually want the VM version of that image, and then that's what it uses. Right now, it pulls that image from the Ubuntu CLAD images.
Is there a way to bridge some image type from used in the KVM?
Oh, okay. So the question is the actual image format in the images. Okay, so the image format we use for LXD VM images is QCOW2. So it's QCOW2 with the LXD .exe metadata on the side for just properties and stuff. But the actual image format we support right now is QCOW2. We'd probably add support for RAW because that's easy. But yeah, QCOW2 is what we use. We're out of time, so if you've got any more questions, you can grab me outside. Otherwise, stickers in front there. Thank you.